We are taking you behind the scenes of the National Institute for Data Science and Artificial Intelligence.
With unprecedented access to the scientists pushing boundaries and shaping our future, this show will take you to the cutting edge and beyond.
And whether you're an expert yourself or just science curious, this is the show for you.
Welcome to the Turing Podcast.
Hello everyone, and welcome to another episode of the Turing Podcast. I'm Ed Cowstreet, and I'm here with my other host for the day, David. David, how are you?
Hi Ed, very well, thank you. So it's my first time as a host today. I was interviewed a few months ago. Together with Aoife, we talked about our PhDs, but today I'm joining as a host.
He's taking over as one of our regular hosts, so yeah, welcome back to the podcast. And today we are joined with our guest, Ellen Pasternack, who is a PhD student in evolutionary biology at the University of Oxford, as well as being a science writer for outlets such as UnHerd and Works in Progress. And we're going to chat to her on the podcast today about one of her recent articles for Works in Progress, which is titled The Stats Gap. And this explores the issues with statistical education for university scientists. Ellen, welcome to the podcast.
Hi, thanks for having me.
So the stats gap, the clue's in the name, but what is the stats gap and why is it important?
The stats gap is what I'm calling the gap between the level of understanding of statistics that you get from undergraduate education and the level that you actually need for using statistics for real life data rather than a textbook example.
Yeah, and we were discussing before the podcast started about how big of a deal this might be, especially depending on the field. I mean, you and I are both biologists. David, what would you say your research specialism is?
Well, yeah, now I'm a data scientist / software engineer, but my background is in aeronautical engineering. And when I read through the article that Ellen wrote, I really felt reflected because it's something that I also experienced. So I feel like that stats gap exists in more mathematically oriented subjects like engineering as well. I wouldn't say it's your background is in biology, but I wouldn't say it's just in biology. I think that it's also the case in subjects such as engineering. I don't know what the situation is like in physics, for example. I am assuming in maths it's
not quite such an issue, yeah.
It's not quite such an issue, but it definitely is an issue in engineering, considering especially now that we're getting so much more data in academic engineering from both experiments and computations, because experiments are becoming much more sophisticated and we're able to get much more data out of our experiments. And the same thing happens with simulations using supercomputers, where from one simulation you could be getting hundreds of gigabytes of data. And is how to process that data and how to actually extract all the knowledge that is there. Because there is a lot happening. Yeah. It's just that we just maybe don't have the knowledge to extract everything that is hidden in that sea of numbers.
And really, like, pretty much science is in the world of big data now. So it's not just like the tech companies, but like research science, you might be dealing with a lot of big data and having a strong understanding of not just which stats tests to use that other people may have half explained to you, but why they're used is important. Yeah,
it's definitely why, I think. Because I think if you don't really understand what you're doing, if you've just been taught at university, like, oh, these are the commands that you should type into your software, then when something goes wrong, which it definitely will when you're using something that's not a textbook example, then you're not really equipped to understand why and to troubleshoot. And I think maybe some people understand it much better than I appreciate, but I think lots of people are just kind of making it up as they go along. Also kind of slightly trying to hide that, worrying that they're the only one who doesn't understand it.
It's interesting, and like one of the reasons which I thought this article was so interesting is that you highlighted this problem of just like amongst, it makes sense when people, you go to study biology, you don't go to like learn stats. We're familiar as people who work at the Alan Turing Institute with a similar problem, which is that if you go into, again, biology or some other field of science, you don't necessarily go there to learn how to code.
Yeah.
And a big part of our job is either teaching people how to code who are scientists, or like helping them with their research code. But an equivalent doesn't really exist for, statistics.
Yeah. Although I will say at my university in Oxford, there is obviously, and I expect in most universities, a stats department where you can go with your problems.
Okay.
But I think that's quite small, and you also have to pay them for it. And
Oh, really?
yeah. Actually, I probably want to check that afterwards because it might not still be the same.
But it's not the norm.
Yes, I remember
yeah.
I tried to ask them for help at one point, and they said they weren't really sure how to help me, and also they were booked up for several months, so it wasn't that useful.
Yeah.
Whereas what I'd love to see would be something like how in each department there's probably IT people that you can just go and poke your head in around the door, or shoot them a quick email if you have an issue, and someone will be able to help you really quickly. It would be really nice if there were department statisticians that you could just in a very informal way go and ask them for help, and they'd be able to advise you, and they're not associated with any particular research group or project. They just help with everything, and I think that would really, really improve the quality of science that the whole department is producing, and it will be also a more efficient allocation of talent as well, because if you just have one person who understands statistics in the department and they're in their group, maybe their group is producing good research, but instead if you hire this person on a permanent basis as the stats person, it would improve things for everyone.
Yeah, I mean, one of the challenges that we've sort of come across in our work, especially, and this is obvious for people who work in computer science, but it will be obvious as well for people who are doing just like any area of science uses stats, is that there is a problem in science in general of like replicability crisis.
Definitely.
In that, like, actually repeating other people's methods is really hard and often just doesn't get done. And I have like there's one scare story that one of our colleagues told us about once, which was like, I think it was from Nature or Science, so like one of the big journals, and like so genes like have gene names which are normally like a few letters or numbers. So it's common for biologists to be or geneticists to be writing papers which are quoting these gene names. But what a lot of them have done, because they're not like us software engineers, and they don't know how to use something like Python or R, is that they're using Microsoft Excel.
Does it turn
into
dates or something?
Exactly, yeah. So apparently some like non-negligible high percentage of like top journal papers have like incorrect gene names that are the result of Excel. And it also hasn't gone down over time since the problem's been identified.
Yeah.
So, yeah.
Going back to your point about having sort of statistics support group in your team, I think that's, and comparing it to an IT support team, I think it's a very good comparison, because you could claim that not every IT knowledgeable person is prepared to work with IT systems with every department. But what usually happens in universities is that you have an IT person which works specifically in one department and therefore gets familiar with the software that is used in that particular field of research. So, for example, during my PhD, in my department, which was an aeronautical engineering department, there was several IT people, but they were very familiar with the software that we tended to use. And they don't have all the details of how fluid dynamics works, but they have a general idea of what fluid dynamics is from just experience and working there for so many years. And then they sort of understand what problems engineers have and how they can solve those problems through IT, through specific software. So a similar thing could be done with statisticians, where a statistician would be someone who is highly mathematically trained. They don't need to necessarily have an in-depth knowledge in biology or engineering, but as long as they're familiar with, the workflows and what type of data those biologists or those engineers or psychologists, whatever, are producing, then, they can support them in the correct way.
Yeah. But it's good that they don't have to have the background in that specific subject, because, currently if you don't have a stats support team, then all the statistics done in a biology department will be by people who are primarily biologists and their interest is in biology, and then hopefully they also have some understanding of statistics. But it's not you don't have to have that selection first. You could just go straight to people who are like primarily interested in statistics and would find it a kind of interesting job to work in a biology department. They don't have to be primarily biologists.
Yeah.
Do you feel like when you are learning the stats that you're supposed to use from the people in your own field, that there's a certain amount of like inherited sort of like accepted lack of knowledge?
Yeah, maybe. I think the issue with stats teaching is maybe a bit more just that it's primarily a biology degree and not maths. And so I was lucky to have really good statistics teaching at school when I was doing A-levels, because it was a core part of the maths curriculum, and that was it was quite difficult, but by the end you would really understand why things were a certain way, and you'd be able to work it out by hand, and derive the formula yourself and that kind of thing. And then I remember being kind of surprised and disappointed that at university it wasn't more of the same. It was kind of much larger groups, and usually in a lecture. And I don't think a lecture is really well suited for teaching statistics. Really, I think you learn much better if it's more interactive and you kind of solve problems yourself, and it's
smaller groups.
I feel like lectures are better suited for if you're just kind of trying to convey information rather than getting someone to quite thoroughly understand something that they might find difficult. I suppose it's just you'd have to make it quite a priority to teach it in that much depth, and that it's going to be competing with so many other things on the syllabus. And also, I think a lot of students just don't like it, and they don't they don't want to have to do loads of maths. That's not what they're there for, and most of them aren't really going to need it in their future lives either.
Yeah, I guess the problem is not just at like undergraduate level, right? It's like actual research scientists, whether they are PhD candidates or whether they're postdocs with a job and already completed the PhD. I feel like, I don't know, it's hard for me to judge how big the scale of the problem is. Like how big would you say it is in your respective fields?
That's really hard to judge. I think it really depends on kind of sub area as well. I think lots of biologists are quite quantitatively minded, but
if I was going to be mean, I would say that even though I've just had a go at geneticists, maybe they probably have better stats than say marine biologists.
Probably,
I would guess.
If
you go into marine biology, you want to go and study coral and stuff.
Yeah, exactly. I think in marine biology or anything kind of ecology adjacent, people go into it because they love nature and they love animals, and that's their main focus. And I feel like we should be able to say that's really good, that people have that, and we can select for that separately from being very kind of maths minded and interested in understanding maths in depth.
Yeah. Do you feel like that part of the blocker to so part of the blocker is clearly not lack of interest in terms of in a sort of dismissive way, but that's not why they got into this subject in the first place. But do you think there's also an element of imposter syndrome at play?
Totally. Yeah. I think a lot of people are really, really, really insecure about how little they understand statistical methods, and are slightly trying to conceal that in a way. I think that's really, really common, and I think it doesn't help because people talk about things in quite a vague way. And you'd be able to have much kind of clearer, more open discussions that were more productive in working out what's actually the best way to do something if there were people who really if we understood it better, basically.
It's interesting because the parallel again to our world of software, I was working with a PhD student the other day, and one of the things I was trying to encourage her to do was to have her code backed up online. So on a public, we use the website GitHub, and it was she was well, I'll do it when it's finished. And I was no. I mean, obviously I tried to explain to her, it's actually, it's good to do it now because then other people can comment on it and give you help and constructive criticism. But then obviously there's a sort of inherent, I'm not sure I want to be have my stuff scrutinized right away and it's not finished. But actually if we can all sort of not be mean to each other about it, that's how science should work. We want everything to be criticized as much as possible, really.
And I think it also possibly means that things might not be peer reviewed as thoroughly as they could be if the reviewers don't really. Speaking of criticising things, yes, if the reviewers don't really understand it either.
Right. So your suggestion is that, like, yeah, if you are, say, a marine biologist and you happen to have done some like hardcore stats on your coral counting or whatever,
then the other marine biologists will
might
think,
not understand it. Yeah. They'll be like, oh, well, that looks really smart.
Yeah.
You know, that's so.
Yeah.
Or they'll be like, I just don't understand this.
Yeah.
I can't review it. You know.
Yeah. Yeah. Perhaps there should be
problem.
like a specific statistician reviewer as well, stats help in the department.
I don't have too much of a background in like academic science and writing papers, but I know from colleagues who are that, you know, that there are huge issues with the scientific publishing, like as an industry in of itself, and like this is one of them, right? It's the having reviewers who are knowledgeable about the subject and like able to do this kind of thing.
Yeah.
Actually, there is a line in your article that I really liked. I can't find it now. But it said something about having basically these people who would work as a statistics support group within the university would be people who are in general interested in science, but they're not particularly interested in becoming huge experts in a very niche field.
Totally, yeah.
And I feel like that's kind of what we do in the research engineering group at the Alan Turing Institute, don't you feel?
Exactly, Ed? This is what I was getting at before, in that like we do this for software. We don't necessarily do this for stats, but
not necessarily for stats.
Although data science is basically kind of
we're not going to get into
adjacent.
We're not going to get into the debate of what data science is. Because it's a tough debate, but no, I think it's a great idea, and as I said, I had a very similar experience during my PhD, and I was also getting the same comment from a lot of people, like, you're doing a PhD in engineering, not maths, you know. So it's like, it's a very difficult problem to solve, and I think there's a mixture of problems, and it's the imposter syndrome is definitely one of them. We shouldn't just blame well-established academics for that, in my opinion, because the amount of work they have is actually unbearable, you know. And someone who's been working in academia for the past, say, 30 years, and all of a sudden has to, you know, get up to date with all these new methods on top of managing all the workload they have at university. It's basically not possible, you know. Like, someone who has been doing maths and pen and paper for the past 30 years all of a sudden has to get familiar with all these new machine learning algorithms and whatever, you know, and all these different programming languages. It's really tough, so we shouldn't blame them. And it's true that is more required implicitly from new PhD students who are starting their PhDs, you know, in the recent years. And they don't have the knowledge necessarily, because that's not something that is well taught in undergraduate courses at university. So having someone with that background supporting an academic team would be very helpful. Yeah.
And I mean, you do have that in clinical trials, for instance. Like, you can have a job as a medical statistician or clinical trial statistician. So I feel like it's just a case of maybe convincing other fields that they ought to do that too. I guess because with a clinical trial,
they have to.
Obviously it's very high stakes, and also it's very, very expensive. So I guess they recognise the importance of really getting it right the first time. Whereas I think in other fields, I mean, it's kind of what we were saying. Maybe this was before we were being recorded, but about how the incentives are kind of set up to produce content. Rather than to efficiently answer questions, whereas in clinical trials, it's leaning a bit further towards
actually finding out whether a drug works or not, because that's going to go into real people in the real world. I suppose a big problem with a lot of research science, and it's not inherently a problem in of itself, because not all research science should be applied science. Like, you've got to do blue sky research that is, you know, 90% chance never going to have a real world impact, but you do it so you can find the 10% that does. But what that means is that it's not going to be held to the same standard as something like a clinical trial with regard to reproducibility and checking that the stats check out, basically. and that the conclusions in some particular PhD student or researchers research is actually, holds up to scrutiny.
Yeah. I think it's probably very, very easy for errors to slip through. Having, actually, maybe I shouldn't say that.
Have you got a horror story to...
No, I was just thinking, like, on my Viva, I was quite nervous about, I don't know, various things that I felt were the weaknesses, and it just didn't come up because each examiner would basically pick a couple of questions for each chapter, and it didn't happen to be the things that I thought were the weaknesses all of the time. And I guess if you have this very long, dense thing, there's just not time to pick apart every single little issue. And I feel the same on the couple of occasions when I've been asked to review a paper. I'd kind of point to the things which I thought were the most glaring problems, but it's...
You can't realistically understand everything. Yeah.
Exactly. I feel like if you... Yeah, there's no way you could possibly catch everything, so I suppose it is.
Yeah. I mean, I'm talking about my experience now again, because I do relate a lot, and I feel like I have my Viva in a couple of weeks, and essentially...
We should say, just before you say that, like, congrats on passing your Viva, Ellen.
Oh, thank you.
You just told us before we started recording that you recently passed, and David, you've got yours in a couple of weeks.
I've got mine in a couple of weeks, yeah, and I'm going through it now. I'm reading it again, and I've written it. I mean, I was the one who wrote it, and I'm reading it now, and I'm like... It's pretty tough to read, like, and it's taking me a long time to read it. So I've spent 4 years doing this thing, and there's so many things to think about, and of course all the details. But how can someone reading your thesis in a month, in the evenings for a few hours, like catch all those little, especially in statistics, like in statistics related subjects, right? It's so hard, especially if it's not let's say hard statistical science, but rather statistics applied to a different science. And the people who are going to be reading your thesis are not heavy on statistics, but rather experts in engineering, for example. It's errors are going to slip through. There's no chance that they can catch everything. That's how I see it.
I wonder if there's like an issue with science in general then. I mean, like most papers are not as long as your PhD thesis, but like the refrain I've heard from other people who've done, I haven't done a PhD, but from my colleagues who have done it, is like, well, no one really reads your thesis anyway. but to be fair, it's not necessarily because of the content, but just because the length, right? It's too long for people to read it.
There's just too much for people to read in general, that no one's going to read the majority of
research.
Relative to the amount of effort that goes in, I feel like the effort that comes out in reading is probably in total number of people that read it is probably much less.
Yeah, and that would be true for papers as well.
Yeah.
Even those papers which do get read quite a bit.
Yeah.
It's still like when I was doing my master's degree, I remember one of the lecturers said and he was, I guess, like 30 years older than me or something, and he was like, well, when I started, you could keep up to date with your entire field by just reading the journals, and like the rate of publication was such that you could keep up with your entire field of what's going on. And he said, like, don't even try to do that now. It's just like, it's impossible. There's just too much research happening.
100%. So we've got to figure out a way of fixing that.
In the length of this podcast, we will fix the science and publishing industry. but yeah, it is interesting. Like, I wonder if the same approach that we're trying to get people to do with code of like, yes, publish stuff in small bursts, have things online as you're working on them so they can be scrutinized. I mean, there's a push in some areas of science towards like more open working and like doing things like, having your online notebooks and things like this. Do you guys both, did you experience this? I know obviously in our job, David, like we know all about this, but in your PhDs or places you've worked in academia, has there been like a push towards like more open working, or is it still sort of you're doing your own thing on your own computer, share it when it's finished?
I think for me personally more the latter, but I guess it's definitely you definitely hear about people doing more open stuff more. So I guess maybe it's just a matter of time.
In my experience, it was the latter as well. So it's also because my PhD was industrially funded. So
you can't just publish.
So you can't just. Unfortunately, that's not something I could do. But it's definitely something that would have helped a lot. Because having things publicly shared, I think, besides the fact that you're sharing knowledge, it also helps you to improve your ways of working. And it's something that could be encouraged. In general, I think that given this data push that we're experiencing now, academia in general should be better prepared for that. So there should be better, not only better stats practices, there should also be better software engineering practices. And it was something that I was discussing with Ed privately a couple of days ago. During my PhD, I felt that there were so many times that the PhD students were making codes, their own scripts for the same thing, over and over again.
Duplication of effort,
And instead of creating a repo where the students could upload their codes and that could be reused by future generations of PhD students, and that could be reviewed and improved, everything was kept. Like, no one shared their code with anyone else unless you asked them privately, and maybe you didn't even know that someone had created that specific script, and that could have solved you a problem and saved you a lot of time. Those practices are not in place, and I feel it's just because we're still at these early stages where the people who are managing university in general are not used to these ways of working yet, and it's something that I hope with time will be implemented better.
Yeah, I feel like for that you just need slightly different incentives, because the incentives aren't really set up for kind of, as a group, let's work out how we can most efficiently answer all these questions. It's much more kind of everyone get on with their own thing because you've got to produce papers in your own name.
Yeah, exactly. This was the idea, like in science, like the incentive at the moment is to publish rather than to find out stuff and do science, and so that is a perverse incentive in that, like it's literally a different goal. So they could be aligned. Like sometimes, like they will be aligned. Like doing good research means also publishing it, but other times it's like, well, if a university group needs to get funding and they need to prove their worth to whoever's funding them, well, they better have some outputs. And if they're just sort of like, well, we did this research and it's sort of on our website, but it's not like published in a journal yet, that might look bad from like the perspective of them keeping their jobs.
But I mean, for instance, if you were setting up a biology department now and you were saying, I want this biology department to answer relevant questions in an efficient way, how should I set it up? You'd probably not, I would have thought, have it so like grouped. You'd probably have, as we were saying, the IT people, the stats people, and then people who do various things, and then some people who'd have oversight of like what questions we want to answer, rather than this group does one thing, this group does another thing.
Just like siloed academic departments at the moment. I can imagine as well, like, because you mentioned like there is this sort of IT support we have, and we were imagining this stats support, but also like just from in a more informal way, I guess there could be more like networking between university scientists who are in the different departments. Like, so there'll be people who are like in a particular maths department, and I don't know whether it comes down to if your particular university happen to share a building with them or something. Like, do you miss out on this like informal knowledge sharing, which at the Alan Turing Institute we're very good at because we all work in a central office, but
it looks like your office is really set up specifically to facilitate that.
It genuinely is, and it was like the office was like, so we have an office in central London, King's Cross, and it was like redesigned after COVID for that in mind, because we used to have some like set desks, now it's all hot desking. And I remember the email going around. They were like, "Oh, we've basically it's set up to maximise going for a coffee and having random sciencey chats with people." So,
but it's also because competitive environment is not encouraged, which I think is not the case in academia. In academia, there is a competitive environment. So I feel like there's always bad vibes between academics, I feel, at university. And, it's not between all of them, of course, but there's always that competition element to it.
Yeah.
And that sort of discourages, positive collaboration and knowledge sharing.
Yeah.
And I feel that is a very big problem in universities still.
It's interesting because I don't know where like people come up with their ideas for like a scientific research project, but presumably like the traditional structure is you have like a group leader who's just like, is their agenda, they're basically the king of the castle. Whereas I feel like here, at least to a certain extent, there's a lot of projects that will come about from people just sort of chatting to each other and being like, this would be a thing that we could work on together, and maybe we could apply for this funding if we team up, and so on and so forth. And I think, my assumption would be that that's much more difficult in like traditional university where the biology department is in a different building to the maths department. But I don't know if we're going to manage to solve that that problem in the duration of this podcast.
I think we've discussed actually a number of challenges. not only one, not only the stats gap, but others as well.
Yeah, I think I would also say to any listeners, don't be put off from working in science and academia. I think people have good stories, and especially if you're interested in like a particular area of research, then that's what you should do. But there are other jobs available, such as research software engineer at the Alan Turing Institute, which is a nice one, being sort of academic adjacent, but not quite having the perverse incentives that we've been discussing.
Yeah, 100%. And I really feel like we fit that line in your article about people who like science but don't want to be experts in a very niche subject. I think that's what actually the research engineering group does.
Not that much space for those people generally. So
not in academia, not really. We try to do that. I mean, part of our job is working with possibly universities in helping them make better software, more robust research software. Like the two projects I'm involved in are actually that. So we kind of do that task, but we're not based within the university. And if the universities had their particular team that dealt with that would definitely help them a lot, in my opinion. So
cool. Ellen, I think we'll wrap up, but before we let you go, is there anything else like about the stats gap you'd like to say, or do you have any? Are you online anywhere you would like people to follow?
I guess maybe Twitter.
What is your Twitter handle?
Is Pasternack E.
Pasternack E. Awesome. Twitter is, of course, the chosen platform of scientists, which was one thing I've definitely noticed. Twitter or LinkedIn, I think those are the two ones. You don't tend to get science.
Really?
Well, maybe you do get sciencey Facebook posts. I don't know, but they're all they're not.
I didn't realise people use LinkedIn that much.
Really? Okay.
I'm clearly out of the loop.
In software, maybe not so much in academia, but definitely in software.
Okay,
yeah, for sure. Yeah. But Twitter was where the scientists are at. So yeah, cool. Well, thanks for coming on the podcast, Ellen.
Well, thank you very much for having me.
Thanks for listening to this week's episode. The show is hosted by me, B. Costa Gomes, Ed Calstry, Joe Dungate, Christina Last, and Anika York. Music for this podcast is produced by Jam and Sun. You can listen and follow via the link in the description or by searching Jam and Sun on Instagram.